Hey, algebra students, we are in our very last unit, so I hope you guys finish strong, and I'm so proud of you all. You've done so well this year. All right, so let's look at factoring quadratic equations. So this is just a review. So on this problem, since our leading coefficient is a 1, all we're trying to think of is two numbers that multiply to give us negative 15 and add to give us negative 2. So our factors of 15 are 1 and 15, 3 and 5. Since we have a product, it's a negative number. One has to be positive and one has to be negative. So it looks like I'm looking for positive 3 and negative 5. Whoops, I wrote a 2. Right there. So once you're done, always make sure you check those. So does 3 times negative 5 equal negative 15? Yes. And does 3 plus negative 5 equal negative 2? Correct. So once your quadratic is equal to 0, you're going to take both sets of parentheses, set them equal to 0, and then solve for x. So x would be equal to the opposite of 3 and the opposite of negative 5. And those are the solutions. In other words, those are your x-intercepts when y is equal to 0. However, sometimes you're going to have problems that you can't think of two whole numbers that multiply to give you letter C and add to give you letter B. So you have to know how to factor those. And that's where the quadratic equation comes into play. Now you could Google videos for quadratic equation. They have tons of little songs to help you remember it, and it really does help you remember. I always think of that song. It's set to the tune of, I think it's Row, Row, Row Your Boat. So I know you don't want to hear me sing, but this is how I remember. Every time I wrote the quadratic equation, I sing it like this. Negative b, plus and minus the square root of, plus and minus the square root of, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. You know what? That was for free, my singing. Or if you just loved it so much, you know, you can send me a donation. Absolutely, I will take a donation. Just kidding. All right, so let's look at this first example. Since our leading coefficient is not a 1, we would think about this as using the AC method. Remember that, where we multiply 2 times negative 8, which is negative 16. And then we want two factors of negative 16 that would add to negative 3. Well, there aren't any, because the factors of 16 are 1 and 16, 2 and 8, and then 4 and 4. Well, no matter how I arrange these with positive and negative signs, I can't get to negative 3, which means I have to use the quadratic formula to simplify this. Now, one thing that we really have to remember is our letters A, B, and C. So whatever is your leading coefficient, or in other words, whatever is multiplied by x squared, that's A. So our A in this situation is 2. Our B in this situation is negative 3. And our C in this problem is negative 8. So now you're literally going to plug in these numbers for each of the variables in the quadratic equation. So this means the opposite of B. Well, the opposite of negative 3 is positive 3. Plus and minus the square root of B squared. So B squared, make sure you put that in parentheses. If you don't, you're going to get it wrong, because if you type in negative 3 squared without the parentheses, your calculator will tell you the answer is negative 9, and that's not right. Anyway, so B squared minus 4 times A times C. All that is under the radical, and then the entire equation over 2 times A. All right, that's what we do. So when I write this, when I solve these types of problems, I take what's under the radical first and put only that part in my calculator. So I'm typing in -3 squared minus 4 parentheses 2 parentheses -8, exactly like I see it. And my calculator tells me that is 73. So basically, I am going to use my plus and minus, and I'm going to separate this into two problems. So I'm going to write 3 plus the square root of 73 over 2 times 2 is 4. And the second answer is 3 minus, the square root of 73 over 4. And sometimes your problem will say, give me an exact answer. That's an exact answer, what we just wrote right there. Those are the two x-intercepts. And sometimes it tells you to approximate the answer, which means you need a decimal. So basically, if it asks you to approximate it, you're going to bring up your fraction button. You're going to type in 3 plus the square root of 73 over the number 4 equals, and I got 2.886. I'm going to write 2.89. And then in my calculator, I'm bringing up my fraction button. I'm typing in 3 minus the square root of 73 over 4. And I use the double arrow buttons. And now my second answer is negative 1.386. So negative 1.39. So those are the two x-intercepts when y is equal to 0. So this is still a positive parabola. So on a graph, it's going to be a happy parabola. It's going to come down here somewhere. I don't know what the vertex is right now, but my x-intercept on this side is almost 3, and on this side, it's about negative 1.4. Okay, so those are still real answers. So even though we couldn't, in fact, we would have said last unit, we would have said that this quadratic is not factorable. Well, it actually is, but we have to use the quadratic formula to factor it. Okay. All right, let's try another one. All right, we're using the quadratic formula. You always identify your A, which is the number multiplied by x squared, your B, which is the number multiplied by x, and your C, which is your constant. So I want us to plug them in. We're going to do the opposite of 1. So negative 1 plus and minus the square root of 1 squared minus 4 times A times C all over 2 times A. All right, so like I said, in my calculator, I always start with what's under the radical. It's called the discriminant. So in my calculator, I'm typing in 1 squared minus 4 parentheses 5 parentheses negative 2, and I get square root 41. Now, you can always try to simplify square root 41. So for example, if you had the square root of 45, that's actually 3 square roots of 5, okay? But square root of 41, 41 has no factors that are perfect squares. So we're going to write our two answers. One of them is negative 1 plus the square root of 41 over 10. And the second answer is negative 1 minus the square root of 41 over 10. So if they want an exact answer, those are the exact answers. If they want an estimated answer, we're going to plug that right into our calculator. Don't forget your radical, 41 over 10. And I got to hit the double arrow buttons. I have, the first one is 0.540. So I'm going to write 0.54. And the second one is fraction button negative 1 minus the square root of 41 over 10. And that answer is negative 0.740. So those are my two x-intercepts right there. All right, so anytime throughout this video when you feel like you can try one of these on your own, I want you to try that, and then you can come back to the video and check your answer. So I challenge you guys to do that as often as you can. All right, let's try the third problem. So our A is 1, our B is 4, and our C is 1. So we're going to do the opposite of 4, which is -4, plus and minus b squared, 4 squared, minus 4 times 1 times 1, all over 2 times 1. All right, I'm typing in just what's under my radical first. So 4 squared minus 4 times 1 times 1. And even if I'm pretty sure I know that equals what, 12, I put it in my calculator anyway, just to be sure. All right, now it is 12. So remember, I shouldn't have said it is 12. It is the square root of 12. Now the square root of 12 can be simplified. So guys, once you get that number of 12, go ahead and see if it simplifies. So when I put in my calculator, square root of 12, my calculator told me the answer was 2 square roots of 3. So don't leave 12 if it simplifies. These two under the radical didn't simplify, and I don't remember what this one was. But square root of 12 simplifies to 2 square roots of 3. So we're going to write -4 plus 2 square roots of 3 over 2 times 1. And then we're going to write -4 minus 2 square roots of 3 over 2. All right, now this one is also a little bit different because when you have all the numbers outside the radical, when all of those numbers can be divided by the same number, that means you get to simplify them. You don't ever get to simplify what's under the radical once you've written it, you know, in the simplest form here. But as long as all 3 numbers simplify by the same digit, then you get to simplify all 3 of them. If only 2 of them could simplify and the other one couldn't, then you wouldn't simplify any of them. I hope that makes sense. So we're going to divide every one of these numbers by 2. So -4 is -2. 2 divided by 2 is 1, and 2 divided by 2 is 1. Same thing here. This is -2. This would be 1, and this would be 1 because we divided everything by 1. So how would I write this now? I'm going to write -2 plus the square root of 3, because 1 square roots of 3 is just the square root of 3. And I'm not going to write over 1. And my second answer is -2 minus the square root of 3. Okay. And then what if I want to get an exact answer? I'm plugging it straight into my calculator. -1 plus the square root of 3 is 0.732. And the other one is -2 minus the square root of 3. And I get -3.732. So those are my 2 answers. All righty. I think that's all on this page. All right, so there's 3 more. Now some of the last 2 are a little different, but all of you right now should be able to stop the video and try this one and then come back and check your answer. So we need our quadratic formula, -b plus and minus the square root of b squared minus 4ac all over 2a. So our a is 2, our b is 8, and our c is 3. So we want the opposite of 8, plus and minus. Woo, that was ugly. 8 squared minus 4 times a times c. All of that over 2 times 2. All right, so I'm putting what's under the radical in my calculator. I get 64 minus 4 times 2 times 3, and I get 40. Well, I'm pretty sure I can simplify square root of 40 a little bit, and I got 2 square roots of 10. So my calculator told me that this right here is 2 square roots of 10. Okay, so I have -8 plus and minus 2 square roots of 10 over 4. Now, I am looking at my 3 numbers that are not under the radical. I'm looking at 8, 2, and 4. Can I divide all 3 of those numbers by the same number? I can divide them all by 2. So that's what I'm dividing all of them by. 4 divided by 2 is 2. 2 divided by 2 is 1. And negative 8 divided by 2 is negative 4. So what are my 2 numbers? My 2 answers are negative 4 plus 1 square root of 10 is square root of 10 divided by 2. My other answer is negative 4 minus the square root of 10 divided by 2. Those are my answers. Those are my exact answers. If it asks me for an exact answer, I'm going to simplify those with decimals, plugged it right in my calculator. Did you get it right? I hope you did. All right, now the second one looks a little different. So remember, you always need quadratics to equal 0. So you need to move this stuff over here so that you can set your equation equal to 0, okay? So I want my leading coefficient to be 1. So I'm not moving my x squared, I'm moving my other 2 numbers. So to get rid of negative 5x, you would add 5x to both sides. And to get rid of minus 2, you would add 2 to both sides. And now I get my quadratic formula the way I want it. My A is 1, my B is 5, and my C is 2. Now you guys try the quadratic formula. So we're going to do the opposite of 5, plus and minus. 5 squared minus 4 times A times C all over 2A. All right, on my calculator, I want to know what is 25 minus 4 times 1 times 2, and my answer is 17. So my answer is negative 5 plus the square root of 17 over 2 and negative 5 minus the square root of 17 over 2. Those are my 2 answers. Okay. All right, what about the third one? Once again, I want my quadratics to equal 0. I want my leading coefficient of positive 1, which means I'm going to move these to the other side over here. Okay, so here's my x squared. I'm moving minus 4x, which means I'm adding 4x to both sides. And now I'm getting rid of positive 5, which means I'm going to subtract 5 from both sides. And that equals 0. So I'm going to do the opposite of B, plus and minus. B squared minus 4 times 1 times negative 5 divided by 2 times 1. So 16 minus 4 times 1 times negative 5 is equal to 36. Now 36 is a perfect square. 36 is, the square root of 36 is 6, right? So my calculator tells me I have this. Well, square root of 36 is 6. So that means one of my answers is this, and my other answer is this. Well, I can simplify that. Negative 4 plus 6 is 2, and 2 divided by 2 is 1. Negative 4 minus 6 is negative 10, and negative 10 divided by 2 is negative 5. Which tells me I could have factored this the way we learned how to do it originally. I could have thought of 2 numbers that multiply to give me negative 5 and add to give me 4. So add to give me 4, but multiply to give me negative 5. Wouldn't that be positive 5 and negative 1? And then if I set both of these equal to 0, guess what I would have gotten? I would have gotten my answers. So the quadratic formula always works, even if you go, oh my goodness, that was a simple problem. Why didn't I recognize that? Well, recognize it or not, the quadratic formula will give you that answer as long as you use it correctly. Okay? So that's a good reminder to all of us. All right, so two more. I want you guys to try these. You got to move your -5 to the other side. Or actually, what we can do is we're going to move over our x squared because we want to get rid of that minus sign. So we're going to add 3x squared to both sides. And we want to get rid of -9 by adding 9. Now it's still equal to 0. So now that I have a positive coefficient, I'm going to bring it up to, I want to write it in ABC order. So 3x squared minus 5x plus 9 is equal to 0. So since I'm using the quadratic formula, the opposite of -5 is +5 plus and minus the square root of 5 squared minus 4 times a times c all over 2a. All right, so in my calculator, I am writing, or I'm typing 25 minus 4 times 3 times 9. And guess what I get? I get a -83. I get a -83. So once you get a negative under the radical, do you remember when we started doing radicals, or back probably in 8th grade, you guys learned that you can't have the square root of a negative number. There's no solution. So when you get to a problem like this, there is no solution. What does that mean? That means there are no x-intercepts. Now, as you get further in algebra, you're going to talk about imaginary numbers, but we're not doing that yet. There's no x-intercept. So how do you have a parabola without an x-intercept? Well, first of all, I wish I could draw a straight line, you guys. Oh, goodness. All right, so imagine this right here tells us, well, it's okay. We can look at this one. So we have a positive parabola. Well, guess what it means? It just means that the parabola is above the x-axis. It's okay, not that you still have a parabola, but if you end up with a negative under the radical, it just means that you don't have any x-intercepts. It's above the x-axis. Or you could also have a negative parabola that goes below the x-axis. That's okay. It's totally fine. All right. Now I could use all these big numbers and plug them straight into the quadratic formula, or since they are, oh, I was about to say, since they're all divisible by 4, they're not. I was totally making that up. All right, so we're just going to use the quadratic formula. We're going to do the opposite of b, plus and minus the square root of -20 squared minus 4 times a times c all over 2a. All right, so under the radical, we have 20 squared, or we have -20 in parentheses squared, minus 4 times 25 equals 0. So under the radical, we have a 0, okay? Which basically the square root of 0 is 0. So whether I write 20 plus 0 or 20 minus 0, my numerator is only 20. And in my denominator, I get 2 times 4, which is 8. So 20 divided by 8, if I simplify that, I get, what, 5/2, which is 2.5. Well, if I only have one answer, what would that mean? That means I have a positive parabola, and guess what? The vertex sits on the x-axis at 2.5. So this one had no x-intercepts, and this one has exactly one x-intercept, and that means the parabola is sitting on the vertex of the parabola is sitting on the x-axis. All righty. All right, so that's kind of what I was just talking about. So when you have the quadratic formula, let me get rid of this. The part underneath the radical which is b squared minus 4 times a times c. When a few things will happen. When you plug this into your calculator, if you get a positive answer, if you end up with a positive answer here, a positive number means you're going to have two solutions or two, it means you're going to have two solutions, or in other words, you're going to have two x-intercepts. All right. If you get a negative number under the radical, or if the discriminant, also called the radicand, both of those words are used interchangeably. If you get a negative number under the radical or the radicand, that means you have 0 x-intercepts. If you have a negative number under there, it means you could have a happy parabola that sits above the x-axis, or you could have a negative, it doesn't matter if it crosses the y-axis, it just will never touch the x-axis. Both of those are fine. Okay, so that's what happens when you get a negative number. And then, like I just said, if you end up with a 0 under the radical, that means you get 1 x-intercept, which means that you either have a happy or sad parabola that's axis sits on the its vertex sits on the x-axis, like these. That looks terrible, but I think you know what I'm talking about. Okay? Those are our rules, or that's what happens when you talk about the radical, also called the discriminant. All right, so we're going to do the opposite of 2 plus and minus the square root of 2 squared minus 4 times a times c all over 2a. So under the radical, I'm typing in 2 squared minus 4 times 1 times 10. And I get negative 36. Well, let's see what this looks like. Let's just go ahead and graph the vertex, which is negative b over 2a. So the opposite of 2 is negative 2 over 2 times 1. So we get negative 2 over 2 equals negative 1. So our x value of the vertex is negative 1. And then we plug in negative 1 to find out what our y value is. So negative 1 squared plus 2 times negative 1 plus 10. So negative 2 squared is 1 minus 2 plus 10 is equal to, what would that be? 9. So negative 1, 9. 1, 1, and then 9. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the vertex way up there, you guys. And guess what? It will go upward, which means it makes sense that I ended up with a negative number under my radical, because I agree, this parabola will never cross the x-axis. Okay? So that's what happens when you get a negative on there, or under there, I should say. All right, let's look at this one though. How about the opposite of 4 plus and minus square root of 4 squared minus 4 times 1 times 4 all over 2 times 1. So in my calculator, I'm doing 4 squared minus 4 times 1 times 4, and guess what I get? 0. That's what I get. That means I have a happy parabola sitting on the x-axis. So let's find the vertex. Let's do negative b over 2a. So the opposite of 4 is negative 4 over 2 times 1. So negative 4 divided by 2 is negative 2. So then when I plug in negative 2, I'm going to do negative 2 squared plus
Group A fire drill, Group A fire drill.
Are y'all in Group A fire drill? You better go outside. All right, so here we have 4 minus 8 plus 4, and we get 0. So our vertex is -2, 0, and it's a happy parabola, which means it will never again cross the x-axis. So once again, we had a 0 under the radical. It only touches the x-axis once, and that's what happens. All right, now Hawks, I always say there's one solution when you get a 0 under the radical, because to me that looks like it's one solution sitting on there one time. However, Florida Virtual says that when the radicand is 0, it says you get 2 identical rational solutions. So when you take a quiz or a test, you need to realize that those mean the same thing, okay? When there's only one solution, when a 0 is under the radical, Hawks defines that as having 2 identical rational solutions, which are both 0. Or no, it's not 0, but it means when you get 0 under the radical, you have one place where your parabola touches the x-axis. Okay? All righty, let's look at these. Now, these are a little bit different than the rest of them because whatever's being multiplied by x squared is our A. Whatever's being multiplied by x to the first power is our B. And do you notice what's missing? We don't have a C, or in other words, C is equal to 0. So we can still use the quadratic formula. You just need to realize that when you plug in for C, you have to plug in 0. All right, what about this one right here? We have our A, 4 is our A. Do we have an X? Nope. Well, any number times 0 is 0, which means our letter B is 0 in this case. And our C is always our constant. It's not attached to a variable, so you can't force it to be B. It's not. -7 is C. All right, so let's see what happens when we look at these two problems. So the opposite of 8, -8, plus and minus. I could have simplified this by pulling out a 4x, but I didn't. So let's just see what happens. So we have x squared, or excuse me, 8 squared minus 4 times A times C, which is 0, all over 2 times 4. All right, so in my calculator, I get 64 minus 16. Nope, not 16, because it's a 0. So 64 minus 0 is 64. Well, the square root of 64 is 8. Oh, it's not a radical of 8. It's just 8. Let me go back. So the square root of 64 is 8. So I'd have -8 plus and minus 8 divided by 2 times 4 is 8. Well, all these can be divided by 8. So I get 1, 1, and 1. So my first answer would be -1 plus 1 divided by 1. My second answer is -1 minus 1 divided by 1. Well, -1 plus 1 is 0, and 0 divided by 1 is 0. -2 divided by 1 is -2. So those are my two x-intercepts. Like I said, I could have factored out a 4x, and then I would have gotten x plus 2, which means if that's set equal to 0, the opposite of plus 2 would be -2. So x plus 2 equals 0. X would equal -2. And if I took 4x and set it equal to 0 and divided by 4, I would get my answer here. So if I'd simplified it before I tried it, I would have got the same two answers. But it's good to also just always show that the quadratic formula is always, always, always going to give you your right answer. All right, so on this one, I can't simplify this. I can't pull anything out of 4x squared and 7. They don't have any common factors. So we're going to do the opposite of B. So the opposite of 0 is 0, plus and minus 0 squared minus 4 times A times C over 2 times A. So 0 squared is 0. So in my calculator, I'm typing 0 minus 4 times negative 7. And I get 112. So I have 0 plus 112. So I have plus positive 112 over 8. And I have negative 112 over 8. Well, what is 112 divided by 8? 14. So my answers are 14 and negative 14. 14 and negative 14. Alrighty. I hope y'all are hanging in there with me. I know this is a long video. All right, guys, so you'll have a problem like this where you are given a total area of your tabletop, and then it tells you basically what is the dimensions of the inside of the tabletop, but you have to calculate the, you got to use these borders as part of your calculations, right? And so it kind of gives you a picture. So this is straight from Florida Virtual. So we have our table. This is going to be what, 32 inches right here, correct? But then we have these two unknown borders we would add into that. And then we see that this, the light brown part of our tabletop is 86 inches, but then we also have to account for these two unknown border lengths as well. So basically, you need to realize that the width of the frame is not just 32, but 32 plus x. This is how we get 2x plus 32. And then the bottom is, or the length is not just 86 inches, but 86 plus this unknown dimension plus this unknown dimension, which equals 2x plus 86. So now that we have our length and our width, now if we multiply those together, we know that it should equal 4,032 square inches. So we would take 2x plus 32, multiply it by the length of 2x plus 86, and that should equal our total area of 4,032 squared inches. And that's what this basically tells us to do right here. So we have to use this formula in order to solve for our unknown, what is it called? Oh, borders. You guys, I'm so scatterbrained. I'm glad. Those of you that watch my videos, I just hope that you're patient with me. If you are, I appreciate that. All right, so anyway, here's our equation. So to solve for x, we're going to FOIL this. We're going to multiply 2x times 2x is 4x squared. And then we have 2x times 32, which is 64x. And then we have 86 times 2, which is 172x. So 172x plus 64x is 236, plus these two numbers squared would be 86 times 32 is equal to 2,752. All right, so since this is a quadratic, we want it equal to 0, but it doesn't equal 0. It equals 4,032. So that means we have to subtract 4,032 from both sides. So we're going to combine our like terms. So we'd have 4x squared plus 236. And then we would have 2,752 minus 4,032, which is negative 1,280. And then I think we could divide everything by 4. We can. So we're going to factor out a 4. So 236 divided by 4 is 59. And 1,280 divided by 4 is 320. So we got our numbers to be quite a bit smaller there, so that's good. All right, so now we could either think of two numbers that multiply to give us negative 320 and add to give us 59. Or, like I said earlier, we can always use the quadratic formula. So since we got these numbers smaller, that's what we're going with. So the opposite of 59, plus and minus the square root of 59 squared minus 4 times a times negative 320, all divided by 2a. So in my calculator, I want to know what is 59 squared minus 4 times 1 times negative 320, and I get 4,761. So that is a perfect square. So the square root of 4,761 is 69. So we would have negative 59 plus 69 divided by 2, and we would have negative 59 minus 69 divided by 2. All right, so let's put this one in our calculator. So we're doing our fraction button, negative 59 plus 69 divided by 2, and I get 5. And then the other one, negative 59 minus 69 divided by 2 is negative 64. Now, this is a word problem, correct? So one of our answers is telling us our border is 5 inches, and the other one tells us our border is negative 64 inches. Is that possible? Can you have a length of a negative amount? No. So when you have a real world problem, you have to use only the numbers that make sense. So if you're talking about speed or lengths or, you know, I can't think of anything else right now, but if you can't have a negative quantity of that, you have to get rid of that choice. So the only answer to this question is 5. The border is 5 inches long. All right, let's look at what Ken did. It says Ken wants to build a table and put a border around it. So this is kind of the same situation. So you should set this one up just like you did up here. So I'm not going to answer this because of the time limit that we have, but I want you guys to figure it out. But hopefully you can use this problem to help you on that one. All right, you will see that question again. I promise you, if you need help on it, let me know. All right, now another one that we have deals with when someone either kicks a ball or they drop a ball off of a specific height. We want to know about, you know, basically what the maximum arc is, and also what the how long it will take this particular ball, or any ball really, to hit the ground. Well, whenever you are talking about velocity has a formula already figured out because it's based on the gravitational pull of the earth. So when we're talking about velocity, we are going to always use this formula up here. So negative 16 won't change. This is going to be the velocity of whatever object that you have put in motion, and our S is going to be at the height of whenever our situation started, okay? So our formula is negative 16 times t squared plus our velocity of 42 times t, and in this situation, our height of where it started is 0. So the first thing it says, approximately what maximum height does the soccer ball reach? So someone's kicked the soccer ball up into the air, and we want to know the maximum height. So do you remember that maximum also means the vertex? So someone kicked a ball, there goes the ball, it goes up, and then it's going to come back down to the earth because of the gravitational pull. So we want to know the maximum height, right? So we're going to use our vertex formula of negative b over 2a. So the opposite of 42 is negative 42 over 2 times negative 16. So we have negative 42. And then 2 times 16 is negative 32. Right? So we have 42 divided by 32 is 1.3125. Now that is when the ball will meet the maximum height. That's when. We want to know what that height would be. So remember, this is our X value. So I'm going to write it right here because I'm out of space over there. This is at what time. I want to know what the height is. So we're going to take that time and we're going to plug it into this equation for t, okay? Because this is what h of t equals. H of t is time. So we're going to plug in -16 times 1.3125 squared plus 42 times 1.3125 plus 0. And the answer is 27.56. I'm rounding it. So what is the maximum height? The maximum height the ball will reach is about 27.5 feet. And if it asks when will it reach this maximum height, this is the answer in seconds. Okay. So this is another very similar situation. Whoops. Oh, I just answered that question. It's the exact same situation. This time it asks how long before the soccer ball hits the ground again. Oh no, this is maximum height. So in order to go back to the ground, we want to know our, how long does it take the soccer ball to hit the ground again? So we're going to set our equation equal to 0. So this time we're going to have to use the quadratic formula. Plus S. So we're got -16 is A, 42 is T, and letter C is 0. So we're going to do the opposite of 42, plus and minus the square root of, because think of this as the x-axis, okay? We started at 0, we're ending at 0. So basically these are our x-axes. That's why we're setting this equal to 0. So we're going to do the opposite of 42 is equal, or excuse me, plus or minus 42 squared minus 4 times A times C all over 2A. All right, so we're going to do 42 squared minus 4 times -16
Brian, or
times
Bingo for
0.
checkout, Hannah Cousins for checkout.
And we get, let's see, 1,764, which is a perfect square. The square root of 1,764 is 42. So we have -42 plus and minus 42 divided by 2 times -16. So the first one, if we do plus, we'd have 0 divided by -32. So that answer would be 0. How long does it take? 0 seconds. Does that make sense? No. So we're not going to use the plus symbol because our answer doesn't make sense in a real world situation. So we're going to use the second part of our answer. We're going to do -42 minus 42. And we're going to divide that by -32, and the answer is 2.625 seconds. All right, so that is that's how long the ball will come back down to 0. All right, 2 more, guys. We can do it. We can do it. All right, now this one talks about a particle is moving along a projectile path where the initial height is 160 feet with initial speed of 144 feet per second. What is the maximum height of the particle? So once again, we're using our -16 t squared plus that's our initial height, and this is our speed. So our speed times t. And now we have a different, we don't have a 0 initial height, we have 160. So when it says maximum, that means the negative b over 2a. So we're going to do -144 divided by 2 times negative 16. So that would be negative 144 divided by negative 32. And I got 4.5. 4.5 seconds, which doesn't answer our question yet. So now when we plug in 4.5 into our equation, we have negative 16 times 4.5 squared plus 144 times 4.5 plus 160. And the answer is the maximum height is 484 feet. That's the answer they're looking for. So you have to use this answer first, plug it into your equation, and get your second answer. All right, once again, this is about gravitational throw or pull. We're going to, a juggler is throwing balls up into the air, and whatever goes up must come down. So we're going to use our same velocity equation. This time, our speed is 15 feet per second. 15 feet per second. And we're starting at a maximum of 4 feet. If the juggler doesn't catch one of the balls, how long does it take the ball to hit the floor? So we want if we're talking about a hitting the ground, you got to think of that as x, the x-axis, which is 0, which means we're going to use the quadratic formula, okay? It's not asking about the maximum height this time. It's asking when it hits the ground, which means that's your x-axis, or 0 on the y-axis, actually. All right, so we're going to do the opposite of b, plus and minus the square root of 15 squared minus 4 times negative 16 times 4 all over 2 times a. So I'm going to put this in the parenthesis or under the radical in my calculator. And I get 481. And 481, well, we'll go ahead and put in our calculators. We'll put our two answers. It doesn't simplify. So we'll put plus the square root of 481 over negative 32 and negative 15 minus the square root of 481 in our calculator. And we're going to have to give a rounded answer. So let's start with our fraction button. We have negative 15 plus square root of 481 divided by negative 32 equals, as a decimal, I get a negative answer. So when we're talking about time, can I say negative 0.21 seconds? Nope, I cannot. However, if I put in the other formula, negative 15 minus the square root of 481, I messed it up, you guys. Negative 15 minus the square root of 481 divided by negative 32, I get a positive 1.54 seconds, which makes sense. It doesn't take very long. Throw up a ball, comes back down immediately. Okay, so that's our answer. So think about what they're asking you. All right, you guys, I know that was a lot. That was a lot, but your test is next week. And then guess what? That's it. You're done. Isn't that great? All right, you guys. Well, let me know if I can help you as you're going through this week and learning all this great stuff. And I will see you guys later.